Hello all, let's start case 3 of section 5.3. Still we are in section 5.3 and I'll discuss in this video with you case 3 of partial fractions, correct? Still we are in 5.3 and we are discussing here case number 3. What is in case number 3 actually? Case number 3 is the partial fraction decomposition when your q of x has a non-repeated prime quadratic factor. It's really important, the word prime. It means if you have in your denominator, which is q of x, of course your form is p of x over q of x. If your q of x is a quadratic polynomial, it should be prime. Prime means you cannot factor it anymore. Now, how to find those partial fractions? I'll put you the method here, then I'll do an example. Look, when we had linear, correct? When we had linear factors in denominator, for example, ax plus b, in the top, you're choosing a constant. Why constant? Because 1 degree less the linear will be a constant. The numerator should be always 1 degree less than denominator. When it was linear, numerator becomes constant. Now, if you have quadratic in denominator, ax squared plus bx plus c, what is 1 degree less than quadratic? 1 degree less than quadratic definitely is a linear. When you write ax, you need another term also, ax plus b, correct? Because you want to write a linear in numerator. That is the only difference in case 3 between case 1 and 2, correct? Let me do an example. Example number 1. Example number 1 is 3x squared plus 17x plus 14. 3x squared plus 17x plus 14 all over x minus 2 times x squared plus 2x plus 4. X squared plus 2x plus 4. Look at the denominator. X squared plus 2x plus 4 is quadratic, but you cannot factor it anymore. It's a prime quadratic. Now, how to set the partial fractions? Copy this one. 3x squared plus 17x plus 14 over x minus 2 times x squared plus 2x plus 4 equals, look, the first factor, your first factor is linear. Then numerator becomes a constant a, denominator your factor, x minus 2. Plus your second fraction, your denominator is quadratic, x squared plus 2x plus 4. Then in the top I should put linear. I used a, then here bx plus what? C. That's it. This part was new for you in case 3. The rest, step 2, 3, 4, until last step, they're all the same as case 1 and case 2. Correct? Now, multiplying both sides of resulting equation with your LCM or LCD. Correct? Then x minus 2 times x squared plus 2x plus 4 times 3x squared plus 17x plus 14 all over x minus 2 times x squared plus 2x plus 4. Equals, same thing, multiply to this side. X minus 2 times x squared plus 2x plus 4 times these two terms, which is a over x minus 2 plus bx plus c over x squared plus 2x plus 4. Let's simplify. Right side, these two cancels out. Now what left on the right side? On the right side I have 3x squared plus 17x plus 14 equals, the first fraction x minus 2 cancels out with x minus 2, then a times x squared plus 2x plus 4 plus this one cancels out with this, x minus 2 left, then bx plus c times x minus 2. Don't think that, oh, x minus 2 already cancelled. No, you are distributing this actually to both of these, right? Remember this. I'm going this method, but be careful that you are distributing, correct? Now simplify the left side. 3x squared plus 17x plus 14 equals ax squared plus 2ax plus 4a plus bx squared minus 2bx plus cx minus 2c. Here I foiled, right? You're using foiling like this. Now you can put in descending order, correct? 3x squared plus 17x plus 14 equals a plus b squared. I did 2 steps in once, right? Because these two are x squareds. Now after that x, which I have 2ax, and also I have minus 2bx, and I have plus cx, right? Then I will write this way. Plus 2a minus 2b plus c and x. Then my constant plus 4a minus 2c. Now equate the left side and right side, equate the coefficients. You can write three equations here. A plus B, because I have a square here, correct? A plus B equals what? 3. 2A minus 2B plus C equals 17. And 4A minus 2C equals 40. Correct? I will not do the rest of this problem for you. I'll stop. This is a very short lecture. I'll stop it here. Please continue and finish this example, correct? Because I just did. My goal was to explain how to deal with quadratic. Solve this system of linear equation in 3 variables, and you are done. Correct? I'll stop the lecture and I'll put case 4 in a separate lecture for you.